Now, welcome to the lesson for Kubernetes pods, deployments, and replica sets. In this, we will be discussing about what is YAML because we will use quite frequently the YAML file to create these pods, deployments, or replica sets in Kubernetes often. Then we'll discuss about the imperative management of Kubernetes object and how do you interact with Kubernetes pods once they're created. Then we'll understand the deployment, a little bit of explanation about replica set, and then finally discuss about the Kubernetes service, which is the networking part of the Kubernetes. Now let's first talk about YAML because we will encounter with YAML quite often. Now YAML, sometimes also known as yet another markup language, or in short YAML, is a simple text-based deployment instruction. It was first released back in 2001, long ago, 20 years back. And then it is known as YAML, but you oftentimes try to see it as a markup language. But no, it is not. It is mainly meant for structuring the data like JSON. So when you use JSON, you basically put the value and the key and you share the data across browsers, the internet, network. YAML is similar to that, but very simple. Now, in terms of YAML, it also gives you a data serialization language, which definitely is not a programming language. So you can't write executables inside YAML, right? And then you just need to provide instruction. For example, when you work with YAML in the deployment scenario, you basically store information about the configuration detail, about the thing like what will be the RAM size, CPU size, etc. It is not something which is gonna give you an executable thing. And the file you store generally gets stored with .yaml or YML extension. You can read and create YAML in any programming language. So it is supported within many different programming languages natively. Now, a couple of characteristics about a YAML. It is human readable. It is short in size. It is mainly used for data portability between languages. For example, JavaScript, PHP, C Sharp, etc. It has a uniform data structure and it is very easy to use. Now let's see how that YAML file looks like in scenario like this. So you can see that key and value is separated by semicolon here. So API version colon v1 here in this case indicates that this is a key and this is the value. And then you have a couple of things. And you see that it also has a hierarchical specification. So a metadata can contain another key like name and service. So it has a indentation. This generally use two spaces. Some people use four spaces, but tabs are not allowed. So we don't use tab. If you use tab, the YAML is doesn't support tab. Now you can have one YAML or more than one YAML separated by this three dashes. So if you use this three dash, you can add more and more YAML into single YAML file. Now you can also add comments in YAML, which essentially means that like a programming language or an executable code or even in HTML, you can have your comment. The comments are generally used with pound or hash symbol. And then you can just say that what you are trying to do. If there is anything special you want to mark, you can mark an instruction over there. Now, one of the things YAML is very popular today is because of its clear syntax. And technology like Kubernetes, Ansible, etc., they all use YAML. And by using the indentation, you basically separate the levels and structure. So if you have hierarchical data, for example, you talk about an employee and his or her salary, so you can put the monthly salary in an indented format under the salary key. You don't need to use any other standard formatting symbol like braces, square brackets, quotations, or HTML tag like syntax. The benefit of YAML is that it is widely accepted. That is number one benefit. And it is mainly used for referencing quite a large or build information. You can also write recursive data in YAML file. It also allows you to specify everything in lines. So you give one instruction in one line and come to the next line, right? So you don't add two things in the same line. Now, one of the few things you can't do in YAML is that you can't really run some executable script. So for example, if you say that I create something and then I run this instruction, which you can otherwise do in Bash or PowerShell, you can't do that in YAML, right? It is very secure when you transfer the files, and then you can actually add executable command in YAML with combination of other languages if you have to do that. So it is not a direct YAML feature, so mean to say, but you can add that if you wish to. Think about the Kubernetes. Kubernetes, we can deploy things using YAML, give all the instruction in YAML, or we can take the imperative approach. So imperative approach is a command line approach. So when you use kubectl, that's a command line tool which Kubernetes provides, which you can run from any machine and connect to any Kubernetes cluster. You can actually create, update, or delete resources in Kubernetes by using that command line tool. Now, for example, if you need to run a pod, you say kubectl run and then the pod name with the detail which we have seen on in our previous demo when we tested our MiniCube cluster. You can also expose that pod or deployment as a service by using kubectl expose. You can auto scale, use that auto scale command to increase the capability and then put things behind a load balancer automatically. So what you need to just say is that you need to say how many number of minimum and maximum pods or deployments you may need to be able to run this workload. And then Kubernetes will create a load balancer on top of it and configure everything for you. So it's fairly simple configuration instruction you can provide through the command line interface. You can do a horizontal scaling of your pods by changing how many replica units you need. So you probably start with one, and then you see a lot of load coming in. So you increase that scale by 2 or 3. You can also use metadata information through annotate. So if you say that, oh, what is the company who created it, when it was created, and for which application, if any other instruction to be added with the object, right? So that if later point in time, once somebody comes in and then sees that object detail, they can see that annotated information. What you add as a command in YAML file does not get saved in the Kubernetes object. But what you get here in annotate stays with the object as long as that object lives. So you should think about adding the metadata information in the annotate field. Level is key component in Kubernetes. Level plays a critical role of associating services with deployments and pods, etc. And deployment observes the set of pods which are being connected by level. So it can allow you to do a lot more things. So you can add or remove level. It is not a mandatory thing. You can create a pod without a level, but having a level will help you control things, and Kubernetes internally uses level quite a lot. To delete any object, you use this delete command, and which will basically be deleting that object from the Kubernetes cluster. So what essentially it will do, it will remove that information from etcd database, and the API server will clean it up. So that's when the garbage collector will come into play, right? To come back and then clean everything related to that thing. Now, you can also view an existing Kubernetes object which is already created by using a couple of different options. For example, there's describe is one such key command which helps you see what is there in that pod. So if you, let's say, create a pod and you want to see about the pod, understand what exactly this pod is, and then let's say what is the a specific container image this pod is using, etc., you can use this describe option. We'll all see them in our demo. You can also get inside a pod information. You can get the YAML output of the pod so that you can reuse the YAML. So if you, let's say, create a pod using the command line, let's say kubectl run, and then once that pod is created, you can use the get command to get the pod output in form of YAML. You can reuse the YAML to create another pod, right? So that's something which quite often is being used in the Kubernetes world. And then, the concept of the pod we already discussed, right? It can host one or more container. So when you create a pod, right, you decide how many containers you want inside that pod. Now, there could be a scenario where application needs some additional thing like logging, etc. So you tend to put things into the pod, right? And then you can create a deployment on top of that pod to ensure that it is being scalable, right? So you can increase the capacity as and when required. Now, Kubernetes reports the health of each process running in the cluster, which means that you have a pod and you have a container. And the basics of the container says that there is only one process which is running in the container. So hence the pod with a single container will run only one process. So it does not do a lot of stuff. So it tries to minimize the activity as much as possible. Now, when you have the Kubernetes pod, right, it gets a separate IP address, and then it helps that IP address or the pod to interact with other pod using that IP address. Now, the configuration information also given inside the pod definition helps pod run or the container run the way you want this to be done. So, for example, you want that pod to be present in a specific node, you can give that instruction with the node affinity. If you want a specific RAM size and CPU number to be allocated for the container running inside the pod, you can also give that. You can even use an external storage through persistent volume. Um, Using that persistent volume mechanism, what you can do, say that, hey, pod, use these files and then store everything in that location instead of storing locally, so that when pod goes down and new pod comes up, the storage is still there and it can reassociate itself to that storage and get all the file back, which is absolutely important. Now, as you know that pod can run multiple containers, right? It simplifies a lot of problem because when you think run everything inside a single pod, what happens, right? You don't need to really think too much about the networking aspect of it because it can now use a local host to interact with each other because they use the same network namespace, right? So because pod gets an IP address allocated and all the container inside that pod uses the same IP address. So you pretty much can interact with all the containers quite locally without bothering about too much about the networking aspect. A pod can connect with another by you using its IP address, right? And then you can also interact with other pod living outside of the same namespace. Now, when a pod starts, a container also starts, which means that the container inside a pod runs when the pod is running. Pod helps you make scalability easier by either duplicating pod or automatically shutting it down. So you can, one of the best ways to use is to through deployment. And if you create a deployment and then say that, hey, I want to increase the capacity, you go ahead and increase the capacity. So the pod kind of scenario, you have the unique internet IP address associated to that pod, right? It also helps you communicate outside of the pod if you expose a port. So, for example, you host an application which is an HTTP application, so you expose the port 80 outside of the pod, so the outsider can use that pod IP address :80 to reach out to the application running inside the pod within a container. You can also have a cluster private IP address, right? So it basically avoids the external communication. And then every pod in a cluster see each other without the use of network address translation. You don't need to set up any NAT. So those are default agreed thing, which is given by default, so you don't have to worry about networking too much. To keep creating the pod, and then you can interact seamlessly. Now, in the pod world, we can create pod in many different ways. So one is directly creating a pod, saying kubectl run and then give the pod name and the image instruction, a pod will be created. But when you create a deployment, it also creates a pod. Something similar happens when you create a job or a daemon set. Uh, they all include pod because at the end of the day, they need to talk or use pod to be able to run container, because pod is the lowest entity available in Kubernetes. So when you think about pod, you can think about pod and as an independent entity, or pod as a part of deployment or jobs, etc. So when you have this kind of hierarchical pod definition, like something else is getting created and then pod is part of it, in the YAML file, you will find something called a pod template, which essentially helps you define the pod just like you define an independent pod inside of the pod template. So we'll see that when we use the YAML file. Now you see here, you have got the template, and inside the template, you have pods. So you basically provide the container details in the specification under the template, and you have this container information, and that's where the pod is getting created within a job. So you can see that it is running a batch job. The job name is hello, and then pod will be created based on this template definition. So that's when you get pod created by default as part of the job. Another thing you can think of is when a pod holds multiple containers, right? And we talked about it earlier as well, because it supports this kind of capability and couple of scenarios where you may need this, right? So basically it co-locates both the container within the same pod, right? It shares resources and dependencies. So if you have a persistent volume, which is an external volume uh, being referred within a pod, just like a map drive, you can have the same persistent volume being used by both the application. So for example, if you have an application and if the log is getting generated, you put it in a storage, and then maybe another container within that same pod picking up that log and pushing it to outside world, right? So that kind of activity is quite common in the multi-container pod scenario. Now, if you see here in the multi-container pod, you have a file puller. I gave this example of receiving value from the volume. So if you think about another scenario where you have a web server running in a container, and then you are getting file from external world, and that file is getting saved into a persistent volume by another container, right? So you don't need to really interact with each other, but they can interact with a common resource like storage. So what happens, your web server is less busy because it is not bothered about pulling the file from external world. The other container is doing only one thing, which is pulling the file from other outside world and bringing it into storage and saving it. So that probably is a long learning activity, and then web server is probably reading that file pretty quickly once it is saved. So in those kind of scenario, you can think of using multi-container. Now, coming to the Kubernetes deployment, probably in real production, we never you create single pod. So we always create pod inside a deployment, right? So that's how it looks like. Now, deployment is holds couple of things. Deployment will say that I need how many copy. So I need one copy, two copy, or more than three copies. And then I need how many pods within that, right? I need a pod, right? So you basically have a pod definition via template, just like you have seen in the YAML example earlier, where we kind of commented about having report created inside a job, right? So this is a setup instruction given. Now you have a deployment created, and it might so happen because you have multiple copies, it might get created in multiple different nodes. Now, what deployment really does via level, right? Because it has a level, it observes the health of the pod. As and when the pod number goes down or one of the pod is down, deployment immediately kickstart a pod into the Kubernetes backend. So it takes care of the number of pod. So when you say that I need the minimum number X, then it basically goes ahead with that minimum number and then brings that thing up. Now, coming to the number of replicas, etc., these are all numbers you can give inside the deployment. And deployment has an ability to go back to the previous state. So it basically manages the back end with the state. So if you have a deployment which is running fine, but you upgraded, and since then the deployment is failing, what you can do, you can go back to your uh, previous state using the rollout mechanism, right? So you can roll back to the previous state. You can roll out with a new deployment. So there could be many different approaches you can take without really going full down in your application space and then spinning up new resources. Now, when you add a deployment to your Kubernetes, it automatically adds pod because you have a pod specification inside the deployment. If by any chance a pod goes down, either the node is not working properly or something has happened, you don't need to handle the pod manually, right? So you don't need to recreate the pod. Deployment will pick up the pod definition and then recreate the pod on behalf of you automatically, because that's what deployment does, sitting on top and monitoring, right? So it is like observer, which keeps track of what is happening with the pod. Now, if you see this picture, right, you have got four replicas, and in these four replicas, you have each pod running three containers, right? So that's the pod definition. So whenever you have a deployment, all the pod within that deployment will be the same because that uses the same pod definition. Each of them gets different IP addresses. They may be in the same node, may not be in the same node, depends, okay, depending on the resources and the definition explicitly mentioned. Whether if you say that I don't want a node affinity, I want them to be separated so that if dependency of the node is reduced, so if one node goes down, I still have other three pods running in other three different physical nodes. So you can give those instructions. You can also eliminate the manual task by associating like scaling, updating, etc. So you can take many different approaches in terms of rolling out new application code. So if you have more than one pod within a deployment, right, it'll probably update one at a time, and then eventually everything in your system will be updated with a newer code. So your end user will not be bothered about that upgrade process, right? So that's how large distributed system nowadays gets their update. Now, in terms of Kubernetes deployment, you can actually roll out a replica set, which basically creates the pod in the background. You can update an existing deployment and change the number of instances you may need within that. You can even create a new replica set within a deployment and then make changes with an existing deployment. If you see that after your upgrade, the deployment is not working as expected, you can always roll back to the previous state. You can scale up your deployment as long as your actual Kubernetes cluster supports them. And then you can update the Kubernetes deployment when you basically think about making changes to a pod. Now, these are the critical component in the Kubernetes world, which happens quite often in for any application development. As you can roll back to the previous state, right? You can actually, if you find any problem with the current rollout, you can undo that rollout also for the deployment. And you can also go back to a previous state by mentioning a specific revision number. So every time you roll out a new version, it adds to the revision number. So you will see the older deployment will have more and more revision numbers, and you can go back to any historical state if you wish to do that. Now you can increase an existing deployment by scaling it out. So for example, you start with 2 replicas and later point in time you decide that I need 10. So if you have that kind of requirement, you can either use this command line to increase the replica, or you go to the YAML file and edit the Kubernetes deployment. It shows you the YAML file. And then in that YAML file, you change the replica in under specification. So you see that you have this 3, you can increase that 3 to 10, and it will start spinning up new pods, and total will be 10 pods. Now, Kubernetes replica set is also an important part, right? So it helps run pod all the time. So you have, let's say, replica set, which uses pod template internally to create new pods. So when you define the replica set, you basically define the pod inside that replica set, and using the level, they are basically connected. So replica set knows which are the pod which it is managing, and then it observes those pods on a constant basis. Now, through selector, it basically leverages the level. So when you see the pod definition, it will have some level, and then in replica, it will use something like selector, which basically reads that level. So it's a simple text. Level is nothing but simple text, but they are very, very important component within Kubernetes to help you build those things. Now, if you see here, Kubernetes replica set, right, which uh, has got a couple of properties, like what is the desired number of replicas you need? That is 3. So at any given point in time, if the current replica set is equal to desired replica set, that's when the replica set is happy about it. If the current replica set goes down, then it'll spin up a new pod in the cluster. So It is another way to observe things automatically without end user intervention. Now, deployment maintains the replica set. So inside a deployment, if you have a pod, it will be maintained via replica set. You will be able to see when you create a deployment in Kubernetes, a replica set is getting created. Now, if you see over here, the replica set template, which gets created when you say there are 3 replicas, and then match level is how it matches the level of your pod, right? So you see that I have a tier front end, and then when I create the pod, I use the level tier front end, and all the pod which is getting created by this replica set will have a level called tier front end, and that's why the replica set knows that these are the pod it need to maintain or monitor, right? So that's the link here. That's why I'm saying again and again, the level is so harmless, but it is so important within Kubernetes. Now coming to the Kubernetes service, right, which is what the network comes into play. You have virtual machines, and then you have pods running container inside the Kubernetes cluster, right? And these virtual machine can be worker node, can be your master node, but they are part of the Kubernetes cluster. Now, what happens when you create a pod and you want to expose it outside of this cluster? Then you need something called a service. So think of it like your network discovery method, right? So you expose your endpoint through the service. So if it is a website or API through HTTP, you expose this service. So services again is a component within Kubernetes. So like deployment, like replica set, like pod, you also have something called service. Now service allocates a name and a unique IP address to cluster IP. To a set of pods, the IP address will not change as long as the service is running. So if you recreate the service, probably you will get a new IP address, but while the service is running, it will not change the IP address. So these are all fixed IP addresses. Now there are different type of service available. Cluster IP is accessed within the cluster. So you get a cluster IP for communicating between the various different things. Then you get node port, which is a static port on each node IP address. And that exposes your service, right? So exposes your pod via service. So basically each of the nodes are individual virtual machines and they have their own IP address. Now node port gives you a port number, and then using that node IP address and the port number, you reach out to the service within that node, right? So that's what node port is. And load balancer is something used in the cloud scenario. So when you have the Kubernetes running in the cloud, use load balancer to expose it via public IP address so that external world can access it. You can also use external name. This is basically returns a CNAME record that maps to a service to a predefined external name field. Now, again, YAML comes back, right? So you can see that it is a service component. So by kind, you say service. And then in the specification, you define the type as node port, and you define all the information about the port, target port, and node port, right? So through that definition, the service will ensure that your application has got this uh, port exposed, and using the node IP address, each of these nodes will have the IP address. You'll see that. Now, in summary, what we have talked about is the YAML file, and which we have manipulated, changed. It looks a bit different if you are doing it for the first time, but it's very simple and accepted. We can use the CLI through kubectl to create all the objects we can create. We have seen the multi-container pod definition, and then we have seen the replica set and deployment and services. So these are the key component of Kubernetes today. So Kubernetes does allow you to create pod individually. You can also create pod using deployment. That's typically the scenario for the real production kind of environment. Now let's see some things in action. Now we have a Kubernetes running in MiniCube from our previous demo. So we set it up just to check if the MiniCube is running. So we'll say MiniCube status. And this is running in my local Ubuntu machine. Now it's all configured. I have a worker node also additionally added to that. That's fine. Now to check if my kubectl is configured, you can see that kubectl is installed. And then to check which um, cluster it is pointing to, I can say kubectl get config view. So just to make sure that you have the config associated, and inside the context, you will see the default namespace is here. The minikube is the cluster which it is pointing to. So you can see that minikube cluster is what it is pointing to, which is a local cluster now for me at this point in time. Everything is fine. Now, one small thing I want to do, which I often do, is that I reduce the typing of kubectl. So I use Alias, which is a Linux thing, so to reduce. So every time I don't need to type kubectl, so I can say k, and it'll basically print out the kubectl. I say k get nodes, and it'll show me all the nodes running here. I say k get pods, it'll show me all the pods. If I say k get pods all namespace dash a, then all the pods running in this Kubernetes. So this means things are fine at this point in time. Now what I need is, first thing, I need to create a pod. Now there are many different ways by which we can create a pod. Let's start with the basic step. Create just the pod. So if I say the default namespace, k get pods, I don't have anything right now at this point in time. Now I'm type k run, that is kubectl run, and then give a name to a pod. So you can give my pod, nginx, anything. That's your name. And this is where you provide the image. That's a container image which um, is available in the registry. So it pulls out an image from the registry and then makes the pod. Now you can see that the pod nginx is created, showing up immediately. Now if I go ahead and then say k get pod, you can see that nginx pod is running. Now, one of the things you can find over here, if you say k run busy and then image busy box, if you do that, what happens? The pod gets created, but this time if you run this pod definition, you'll see the status different. You see that busy box is completed. Now, if we go back to the understanding of the container is a very small component and it does one process. So you on inside a container, there is only one process which is running. Because BusyBox is a bare minimum Linux container, it only run once and then comes out. Now, Nginx is a web server, right? So it is constantly running to serve the web traffic, right? So it can be used for many different activities. But imagine that it's a web server running. Now it will not go down. So this is designed such way that it'll keep running. So as long as the container is doing something, you can actually see this is running. Otherwise, you will see it is completed and it is done, right? So there is one restart happen. If I see get pod, there are three restarts happen, and then crashed loopback. So there is some issue with that happening with the BusyBox, right? But with the Nginx, it's still fine. So you might find these kind of behaviors quite often when you create the container. Now let's see about the pod which you created, that's Nginx. Now since the BusyBox is not running, right, we'll delete that. So we'll say that a delete pod and then give the pod name busy and it will be deleted. Now deletion sometimes takes longer time. So you can give the instruction like delete immediately and then it will be deleted. Otherwise, it might take a while to get things deleted because the uh, garbage collection may take longer time. Now there is only one pod Nginx which is running. There is no restart. Everything looks fine. Now let's get inside that. So I can say kubectl get pod and then pod name Nginx. If I do that, there is no Nginx. You can see that the pod is coming. That's fine. Now if I use this a get pod, I said describe, it'll go inside the pod. Now this gives me a bit more additional information. So I'll go down and then I start from top. So I said describe, it gave me the name of the Nginx and it is running in which node. It is telling me the actual node information, the physical location, when it started, what is the level it is using. If there is an annotation, there is nothing. Current status is running. That's the IP address of this pod. Okay. So what I'm seeing here is the IP address of the pod. Now it also talks about the container it is running, right? So because pod inside a pod, there is a container which is running. So I see the container information about like what is the image. So I get the image from somewhere, right? That's the Nginx. And then that's the image ID. That's the Docker Hub image. And all these details are coming up. Not only that, it also, if you go down, it also gives you the log, right? So you get to see the log coming in from the container space and you happen to see things coming up over here, right? So you basically get all the values of the log which has been produced over here. Now, this is sometimes important when you deal with, let's say, a large amount of workload and you need to monitor. So you basically do the monitoring through this logging, and this can be populated and then pulled in into the pod infrastructure. Now, coming back to this, let me just clear it up. So I get the pod. Now I can get the pod in a couple of different ways. So I have seen that if I say get pod, it just shows me the pod details, right? If I say O white, this gives me a bit more additional information, right? So that's something which is more than what default really gives me. So I get to see more information, which is helpful in certain scenario. So I see the IP address also. I see the node where it is running. I see other things like readiness states, nominated node, etc. So that's all given to me. But I need more. What I need is that I need this as an YAML. So you can say that give me the created pod as an YAML. So you get the YAML on the screen itself, right? It not only gives you the definition in form of, let's say, what it needs to create a pod, but it gives you all the detail. Now you can store this YAML into a file. How do you do that? Use this and then use this pipe command and then say that pod.yaml. Now what happens? This file gets created. So I go to this pod.yaml and then I open it in my VI editor. You can just edit it anywhere if you wish. So the YAML file is kind of visible. Now there could be things which you don't need. For example, this metadata you don't need. You don't need the namespace to be explicitly mentioned, resource version, UID, and then you have that specification of the pod, which contains the container image policy, right? Nginx, there is no resource. It comes from the option, right? You delete all the unnecessary stuff you probably don't need anymore, right? I don't need all these things. I don't need DNS policy, enable service link, all these other details, which is coming from the Kubernetes world, right? So I can pretty much delete everything and can actually create a pod um, pretty quickly by having that definition. Now, if you see here, I have deleted almost all the values. Okay. Now you go ahead and delete this. So you basically say that image nginx, name nginx, and then if you go to this metadata, label it like nginx, maybe you can add 2. That's the name of the pod. Now, that's how my pod uh, name level would look like. Now I can just get rid of that also because I don't need level. It's not mandatory. So if you see here, my pod definition is fairly simple. So it's the name of the pod, right? And then the specification, which contains the container image and the name of the image, right? So if you leave this part only up to this, so that is your pod.yaml. And it starts with this API version, which is what is the API you are using right now at this point in time. And then I'm going to create a pod. So that's what kind is saying. And then you have the metadata information, which is the name of the pod, and then which is the container image, what it tries to bring. That's all. Now, if I just save it and come out of this, and you can see that, like, if I go back and check the pod YAML out again, you see that now I have this simple pod definition. Now, to use this pod and create a file out of it, so I can say, now if I just go ahead and then clear it up, let's just clear things up a bit more here. And if I go ahead and say that I want to create a pod from that YAML. So far what we have done is that we have created a pod using kubectl run. Now we'll use this file, that's our YAML file, to create this pod. To create any Kubernetes resources from the YAML file, which is written perfectly fine, we use kubectl create, and then we say f, and then we give the file with a path. Okay, if you do that, now you can see that pod nginx2 is created. The magic happens. If I say k get pod, I have 2 pods, nginx and nginx2. The nginx2 is coming from that pod. Now you can also delete a pod from the YAML. So if you use a YAML to create a pod, you can use that same YAML to delete a pod. So to delete a pod, k delete -f pod YAML. And it'll say that pod nginx2 is deleted, right? And once this is deleted, it will come back and you will see that nginx2 is no more available. To create nginx2, use the same file and then say create pod, and it will be created. So it is very easy to create Kubernetes object through YAML. Now, as I said that you can have, let's say, more than one YAML definition inside YAML file separated by dash. So if you, let's say, want to create deployment, services, pods, etc., all in the same file, you can pretty much do that. Only need to remember that you need to have 3 dashes, right? So that will basically help you uh, build a single YAML file. But always recommended that you keep the YAML as short as possible so that it is easy to maintain and you can have multiple YAMLs available and call one after another. Now let's see the deployment. Now we have seen the pod is fine, the deployment, let's see the deployment. Now to create a deployment, you need to say kubectl deployment. I'll say get deployment. So there is no deployment available. I say create deployment. So you need a couple of things. Now, for example, when you are exploring things out, and if you don't know, you can always get help from the kubectl command prompt. So you say that create deployment help, okay, and it gives you a bunch of information. So you can see that it also gives you some example about how you can create a deployment. So you say create a deployment, give a name and give an image. That's all mandatory. Rest all are optional. So if you go ahead with that approach, okay, and say clear it up, and I say create, and you can also use a shorter form called deploy. You don't have to type the whole deployment thing again, and then give a name, nginx dep, okay, and then you say that image will be nginx. Okay, see here, the deployment is created with this name. I say get deploy. I get a deployment nginx, and I can see that there is only one instance which is running, right? And if I now see the pod, I say get pod, I see another pod which is this one, right? So we had previously nginx 2, delete pod nginx 2. So let me just clear up what is not necessary here. Now I have only 2 pods running, right? The second pod, which is basically the pod which came from the deployment, has got some random value at the end, right? So you can see. Now this is what deployment generates, because when I create a deployment, I did not say about anything about the pod. Now to know about this, so you say get deploy, and then say nginx dep, that's the name of the deployment. You see this, that's fine. You say wide. You see a little bit of information about deployment. You see the selector, that's the level which pod is using. That's how the deployment is monitoring the pod. But if you say that I want the YAML version of it, and then probably put it in a file so that I have a little color in place. Now I open this file in VI editor, and I say dep.yaml. Now you notice here in this, I have got couple of additional information, right? It's on the spec. It says replicas, right? And it has got revision history limit, which means how many revision history it can uh, get up to. And then it has got strategy about the rolling update, and the template is where actually the container specification or the pod specification is given. So it uses an image and all this other information about the container. So what I can do, I can take this file and change the number of replica, or I can change an existing deployment. So I can say kedit deployment, and then I say nginx dep. If I go ahead, now you need to understand one thing. It is not going to allow you to modify everything. So only there are certain fields which you can modify. So the best way to modify an existing resource is to delete that and then recreate, right? So I can actually delete this, and let's say put a replica 3. It was earlier 1 and I put it 3. So I come out and it says that it is edited. Edited means it is kind of modified already. So let me bring it up and I say get pod. Now you'll see 3 pods running under Nginx, okay, because I have modified them, right? So they are kind of spinning up now. Now, what happens when you, let's say, delete a pod explicitly by hand? So you say delete the pod, you pick this name up from here, you delete it. Okay, so remember that JK6WW, which ends with JK6WW, is going to get deleted. Now, as soon as it gets deleted, now I say that you watch it. Now you can see that new pod is running, right? So there is a new pod which is running because one got deleted, right? So if you, let's say, see that JK6WW is no more available, but it maintains the total number of 3. So you can try deleting all the pods over here, which can essentially help you with the with the cleaning process due to some maintenance, but deployment will make sure that the pods are deleted. So that's why when we say that we don't create pod, we create deployment. This is specifically the reason, right? So you can actually increase or decrease the capacity. So if I, let's say, increase it again, I want to go ahead and edit this deployment, and then I come over here and I go at the end of it and then say increase it to 5 and then save. As soon as I save and everything is fine, you will find there'll be 5 pod running in my local cluster. So because I increased that, and some of them are pretty new. You can see that 6 seconds ago, these are all 2 new additional pod which got added. These were the older ones which were there previously. So you always see that even if you delete or by mistake you remove it, it goes ahead and gets them. Now if I say k get all, okay, if I just do that, now you see that as part of this deployment process, right, there is a replica set which automatically gets created. This is also kind of like associated to this deployment. It says that desired state is number because I said that I need 5 instances in deployment. Current is 5 and ready at 5. So everything is fine. It's monitoring my deployment. The number of pods are getting controlled by this replica set. So you don't need to explicitly create a replica set. Deployment will create the replica set for you. If you eventually reduce this number to, let's say, 3 or 2, right? The replicas to 3 or 2, okay? And then you just save it, come out, and now you see that detail. You see the replica set sets back to 2 because you changed the deployment to 2. Now, if you see what is there inside the replica set, you just need to say get this, and it gives you the detail, right? And you say YAML, and then you say rep.yaml, and it will be saved, and then save vim rep.yaml, and that's the replica set definition, right? So inside the replica set, it says the specification as number 2, right? And then you see that replica set uses the level, that is Nginx depth. That is the level which is being used by the pod and etc. So you see that the owner of this replica set is the deployment, right? Which has got a level. So that's how they connect with each other. So there is no ID or GUID or anything of that sort. They use simple plain level to interact with each other, right? So if you give a proper name for the level, it becomes much easier for you to really figure out who is talking to who is monitoring whom, and then what exactly is happening. By the level, you can fetch the resources within the Kubernetes cluster and then find out all the related resources, let's say for this deployment or for the replica set or the pods associated to the deployment. Now, last but not the least, what I'm going to show you is I'm going to use this deployment that is nginx step and then say k expose. Now you notice here we have only one service under the service category, that is the Kubernetes service. So I'll say k get deploy, okay, and then I say nginx dep, right, and I say port 80. Now I am exposing this nginx via port 80. Now say k get svc, that's shorter form of services. You can see now nginx step is showing up. Now the nginx step has got certain value, and I say wide. You get this nginx step having some cluster IP address, and it uses port 80, right? If you go deeper into this thing and say YAML, now if you just print it out locally, you will see a couple of things, right? For example, if we go down, this is the specification which uses the cluster IP address. And this also tells like what all ports I'm opening. So I'm opening port 80. Okay, this is a TCP port. And when you connect this cluster IP colon 80, it reaches out to the container with the port 80, right? So if you have an application which uses a specific port, you should expose that port to the outside world, right? And then you can actually map it back to the internal one. So that's how the services is doing. So now if I delete the services, it will basically delete individually. So it is not connected to deployment so tightly. So I can say k get all, and that will give me the list of things. And I say k delete dep. So now delete the deployment altogether, which will delete the replica set as well. So I will just pick up the name and then I say this, and then it will be deleted. Deploy, and then it will be deleted. Now, if you say k get all, that's gonna go ahead and show me only the services. Now see, the service is still running, but it is unable to map to a deployment. As long as there is a deployment with the level it is observing, then it will work for that deployment. The moment the deployment is gone, the service is not gone. It's still available in Kubernetes. So what you need to do, you need to explicitly delete this service because they are disconnected and loosely coupled. K delete svc nginx dep. To do that, then now the service is also deleted. Now you see pretty much the old state back where you have this single pod running without deployment, and there is a default service for Kubernetes also running. So hope this was helpful in terms of understanding what pod really talks about and how you create a deployment, increase the number of instances, and deployment internally can create replica set. And you see that replica set also is connected to deployment. So by default, if you create deployment, replica set gets created. If you delete the deployment, that same replica set gets deleted. However, but if you create a service, it doesn't get deleted the moment the associated components are deleted because they are loosely coupled. And you need to delete the service separately if you have to delete it. So with this, I think we are done for the demo. And thank you very much for watching this presentation.